Hello everyone, I hope you all are fine with your families, safe at home. And during this time of pandemic COVID-19, we care about your studies. So I should be going to start your math syllabus. So let us start. So let us start class 7. First chapter is integers. First of all, let us discuss about natural numbers. We all know what are natural numbers. Counting numbers starting from 1, 2, 3 and so on. These are natural numbers. Then if I take negative of natural numbers, then it will be -1, -2, -3 and so on. And 0. This is absence of something. Right? So 0 is neither positive nor negative. And these are collectively known as integers, as you can see on the number line. Here it is 0 in the middle. On the right side we have natural numbers 1, 2, 3 and so on. On the left side of 0 there are negative of natural numbers, that is -1, -2 and so on. These natural numbers are called positive integers and negative of natural numbers are called negative integers. And 0 is neither positive nor negative, as you can see. So this is about integers. Now every number on the number line is greater than every number on its left. As you can see on the number line, let us take any number, suppose 2. So all the numbers which are on the right side of 2 like 3, 4, 5, 6, all these are greater than 2. And the numbers, the integers which are on the left side of 2 like 1, 0, -1 and so on, these are lesser than 2. So the number which is on the right side is greater than that number and the number which is on the left side is lesser than that number. So we can say that every number on the number line is greater than every number on its left. And the next point is, if a and b are two integers and a is greater than b, then -a is less than -b. For example, 3 is greater than 1, we all know. But if I take negative of these two numbers, so I have -3 and -1. Now let us see on the number line. -1 is on the right and -3 is on the left. So we can say that -1 is greater, obviously. So -1 is greater than -3. So the sign will be just opposite when the signs are opposite. Similarly, 7 is greater than 5. When both the numbers are turned to negative, -7 and -5, then -5 will be greater because -5 lies on right side in the number line. Then we come to absolute value. The numerical value of an integer regardless of its sign is called the absolute value. Means in absolute value you don't have to show negative sign. It's just the numerical value. So 2 points you have to keep in mind about absolute value. Absolute value of an integer is always positive because we don't show negative sign here. If it is negative, we remove the negative sign. So it is always positive or it can be 0. And it is denoted by the symbol. This is called mod. If I denote the absolute value of x, then I write mod x. Here is an example. Mod of -5, that is absolute value of -5. Because it is negative, we remove the negative sign and it will be 5. Mod of 5, it is already positive, it will remain as it is. So mod 5 is equal to 5. So you just have to remove negative sign from the number, you will get absolute value of that number. This is the formula. As you can see, x, if x is positive or 0, it will remain same. If it is negative, then we take the negative of x, so that negative of a negative number is always positive, so it will be turned to positive. Now there are some rules for adding the integers. Whenever you have to add two integers, here are the 4 rules. In these 4 rules, see the first one, when both the integers are positive, then the sum will be positive and we will add the integers without considering the sign. When both are negative, then the sum will be negative and again we will add the numerical value of both the integers. If one of them is positive and the other one is negative, then sign will be of the greater number and we will subtract the smaller number from the greater number. See how? Here are the examples. According to rule 1, when both the integers are positive, I have taken 2 and 3. Both are positive integers, right? When we add them, it is written here the sum will be positive. So I have put a positive sign here. Now add the integers 2 plus 3. Simply we have to add the numbers 2 plus 3. It is 5. So the answer is plus 5 or simply 5. It is not mandatory to mention the plus sign here. Now according to the second rule, when both are negative, I have taken both the integers negative, minus 2 and minus 3. When we add negative integers, you can see here the sum is negative. So I will put a minus sign here. Simply add the numerical value of the integers. Numerical values are 2 and 3. So 2 plus 3 is 5. So your answer is minus 5, right? Now one is positive and second one is negative. So I have taken positive integer 2 and negative integer minus 3. When we add them, I told you sign will be of the greater number. Now out of 2 and 3, obviously 3 is greater and here 3 is negative. So I will put a minus sign because the greater number is negative. Now you just have to subtract the smaller number from the greater. 2 is smaller, subtract 2 from 3. So 3 minus 2 is 1. Your answer is minus 1. Now if I take first integer negative and second integer positive, I have taken minus 2 and plus 3. Again, one is negative, other is positive. I told you sign will be of the greater number. Greater number is 3. 3 is positive. So the answer will be positive. Now you have to subtract smaller integer from the greater. Smaller is 2. 3 minus 2 is 1. So answer is plus 1 or simply 1. So you just have to apply these 4 rules. You can see whether both the integers are positive or both are negative, or one is positive and other is negative. So you can apply these rules for addition. Now one thing to keep in mind, negative of a negative integer is always positive. Negative of negative 2. So again it will be plus 2. Similarly, minus of minus 1, it will be 1. Minus of minus 7, it will be 7. So whenever two negative signs are together, it will turn to. Now subtraction of integers. See some examples. We can do this with the rules we have just read. See here an example. Subtract minus 7 from minus 15. So the number which is written after from is written first, minus 15 minus this integer, minus 7. Now minus 15, I told you negative of negative integer is always positive. So minus and minus will become plus 7. Minus 15 plus 7. Now see here, one integer is negative and the other integer is positive. So I told you sign will be of the greater one. 15 is greater, which is negative. So answer will be of minus sign. And you will subtract lesser from the greater. So 15 minus 7, your answer is minus 8. Similarly, see in this example, 13 from minus 9. Minus 9 minus 13. Here both the integers are negative. So answer will be of minus sign and you will simply add the numbers. It is minus 22. Similarly, here are some more examples. 9 minus 13. Minus and minus will become plus. 9 plus 13, 22. Similarly here, 7 from minus 2. Minus 2 minus 7. So minus 2 minus 7 both are negative. Answer will be negative and 2 plus 7, 9. So it is minus 9. Similarly here, minus 11 minus 3 both are negative. Answer will be negative. 11 plus 3, it's 14. So your answer is minus 14. Clear? Now let us come to some properties of addition of integers. First property is closure property. What does it say? When you add two integers, the sum is also an integer. So this is the statements. If a and b are integers, then a plus b is also an integer. Let us see with the example that it's true or not. I have taken minus 5 and 3. These are the two integers. When I add these two integers, one is negative, other is positive. It is minus of 5 minus 3, that is minus 2. Minus 2 is also an integer. So it is 2. Integers are closed under addition. Now commutative property. Commutative property means when you add two integers and if you change the order of the integers, the sum will remain the same. See here, a plus b is equals to b plus a. I have taken an example. Let us take in place of a 6 and in place of b minus 11. So first I will add 6 and minus 11, then I will add minus 11 and 6. So 6 plus minus 11, it is minus 5. Minus 11 plus 6, this is also minus 5. Both are equal. So it is commutative. Now in associative property, what we do, it is a plus b taken in a bracket. Then to the sum of a plus b, we add c. And on the right hand side, we add a to the sum of b and c. Right? If both the sides LHS and RHS are equal, then it is associative. Now let us see with the help of an example. In place of a, I have taken minus 1, value of b is 2 and value of c is 3. So according to the left hand side, this will be the equation. And according to right hand side, a, that is minus 1 plus in bracket b plus c, that is 2 plus 3. In left hand side, minus 1 plus 2 is 1 plus 3. So 1 plus 3 is 4. In the right hand side, minus 1 plus 2 plus 3 is 5. Minus 1 plus 5, 4. So LHS and RHS are equal. That means in addition, order does not matter. Next property is additive identity. If a is any integer, then we can say that a plus 0 is equals to 0 plus a is equals to a. What does it mean? Additive identity is actually that number which is added to a number, the sum will remain the same. So if I add 0 to any number, the number will not change. The sum is also equal to the number. Like 3 plus 0, the sum is also 3. Number is not changed. So 0 is the additive identity. Then additive inverse. If a is any integer, then there exists an integer minus a such that a plus minus a is equals to 0. So additive inverse is that number which is added to an integer, then the result will be 0. So if I have the number 7, if I add minus 7 to 7, I will get 0. That means minus 7 is additive inverse of 7. Similarly, 3 is the additive inverse of minus 3. Because in minus 3, if I add 3, then the sum will be 0. So minus a is called the additive inverse of a. Now there are some properties of subtraction of integers. First one is closure property. Again, as we have discussed for the addition. Here, when one integer is subtracted from the other integer, the difference is also an integer. Let us see an example. 11 minus 6. 11 minus 6 is 5, which is also an integer. Similarly, minus 13 minus 2. When I subtract it, it is minus 15, which is also an integer. So integers are closed under subtraction. Next property is commutative property, as we have discussed, but in this case for subtraction it does not hold. A minus b is not equals to b minus a. How? See with an example. I have taken a as 3 and b equals to 5, right? So in the left hand side, let us see a minus b, that is 3 minus 5, it is minus 2. And according to RHS, b minus a, that is 5 minus 3, it is 2. Minus 2 and 2 are equal? No, it's not equal, right? So commutative property of subtraction does not hold true in integers. Next property is associative property. If a, b and c are integers, then a minus b taken in bracket from this sum, if we subtract the third integer, it will not be equal to a minus difference of b and c. Right? See with an example, I have taken value of a 9, b equals to 3 and c equals to 4. According to left hand side, 9 minus 3 in bracket, 9 minus 3 is 6, 6 minus 4 is 2. Here 9 minus, in bracket we have 3 minus 4, 3 minus 4 is minus 1, minus and minus will become plus, 9 plus 1, 10. So 2 is not equals to 10, right? So associative property of subtraction does not hold true in integers, right? So this is all for this lecture. In the next lecture, we will discuss the exercise.